All right, this is the study hall for June 4th, 2015. It's already June. Incidentally, it's the third anniversary of integrated reasoning, which was rolled out at the beginning of June 2012. So everybody wish integrated reasoning a happy third birthday. All right. Same theme as before. I've collected a handful more problems of data sufficiency with setting goals, which mostly means in these weird yes-no questions, just making sure that you know what the heck you're even trying to do in the first place. But you'll see. Here's the copyright notice. These are from the free GMAT prep software. And except as otherwise indicated, our copyright GMAC. And please use the multiple choice questions that are underneath your name. Let's do one. This is data sufficiency. Does anybody need the answer choices to be posted on the board? Like the actual meanings of choice A, B, C, D, E here? Does anybody need that? If so, then tell me in the chat and I can post them. Remember that we do assume a baseline level of understanding of data sufficiency format here. But if you do need those answer choices, then let us know in the chat. If not, then go for it. All right. If you guys are still doing work that is productive, you should keep doing it. But if you are not, you should definitely have a guess on the board by now. Okay. Andrea, Audrey, Chuck, Frank, Gloria, Glenn, King, Linda, Priya, Vince, I think that is senior Nair. Okay, so let me tell you what just happened, because it shouldn't be what just happened, but it is what just happened. What just happened is that Ron said, hey guys, it's time to stop, and immediately 16 of you put up answers. That's kind of a problem, because when you take the test, there's not going to be a Ron to tell you to stop. So just make sure that it's you that tells you to stop. If you're relying on Ron to be like, time to pick an answer, guys, then that's a point of improvement. So just make sure that you improve it as your progress progresses. Okay, let's talk about this problem. What is the goal of the problem? It's one of those yes/nos. Does anybody remember the big take-home point from last time about yes/no data sufficiencies? Like, what are you actually trying to do when one of these yes/no style questions is put in front of your face? King, how do you prove that? I'll talk about that after we discuss this problem. That's a good question, actually. Yeah, you want to change them to concrete goals, right? Yes, you do. And it's always kind of the same concrete goal, right? The word yes and no, those are your enemies, because they are not things. I mean, you can't dither around with numbers and suddenly the word yes pops out. It's not a thing, guys. It's not a thing. Like, you want to work with things that are actually things. What I mean by that is stuff that is specifics in terms of what is actually in the problem. So just remember, when you are presented with one of these, when you see a yes/no data sufficiency problem, first thing you should do is translate yes and no into the specifics of the problem. this is the most important step, because honestly, those are the goals. And if you don't do this, you don't really have goals. You're not really trying for anything that is specific. So after this step, you should never be thinking about the words yes and no ever again. No, those are impure thoughts. Don't think them. No more thoughts of the words yes and no. Don't do it. Impure thoughts. They're specifics. All right. Then just there's a device that I have shown you in previous classes for this. So let me just remind you what that looks like. So the yes to this question is that A sent at least 10 reps. And what is the no to this? Well, what does no mean here? It means that A sent what does it mean if the answer is no to the question? It's less than 10, but what is a more instructive way to write that? Because remember, whole numbers here, representatives, you can't have like that. Yeah, 9 or fewer is better, because that's more, there's a boundary value there that's actually a real boundary value. Right, if it was continuous variable that's not like a number of people or something, then it would just be greater than or equal to 10 or less than 10. But the thing is that less than 10 is, if you write less than 10, it makes you think 10 is the boundary value. But it's not really, the boundary value is 9. So this is, there's a take-home point here as well, which is that when you have whole numbers, it helps to change all statements of this or this into that or that. For example, saying that a whole number is less than 9 or less than 10 is the same as a whole number is 9 or less. Because then you're looking at the maximum, right, as opposed to not looking at the maximum. It's always better to be actually looking at it. So, all right, and then I would strongly encourage you to set up this device on your paper. It's very simple checkboxes, but set up a device with these specific goals on it. So this is the device that I'm always urging people to use. So statement 1 is going to be on there, and statement 2 is going to be on there, and both is maybe going to be there. If you have to combine the statements, that last column is going to be both. If you don't have to combine the statements, you just don't use that last column. So remember how this works. Basically, if you can put check marks in both boxes in a column, then not sufficient for that statement. That's how this works. So notice, I mean, this device is really cool for 2 reasons. The first reason is that it will constantly remind you of what you are trying to do. Which, yes, you really do need reminders. Trust me, you do. Like, it'll remind you over and over again that you have to try to make A 10 or more, and then to turn around and try to make A 9 or less. It'll remind you of that, which is cool. But just as important is that it is a thing. Like, it's a thing. It's a step 1. It's something you can start the problem with. Because a lot of people are like, I freeze and I don't know how to start these problems. Now you have a way to start all of them. Every single one of the yes, no's. You can just make the device. That's the way to start it. Then solve the problem with those goals in mind. So solve in a way that's always aimed at the goals in the device. Okay. Yes. All right. 6 countries. Sent a total of 75 reps. and no two countries, so we got 6 different whole numbers. So let me just flash a graphic on the screen that you've seen 1,000,000 times if you've watched enough of these things. But for any data sufficiency problem, basically there's 2 ways to attack it. You could either use theory or algebraic methods, or you can just test cases. Which of these are we going to do here? In a problem with 6 different whole numbers. What's the only reasonable way to do that? You're going to definitely have to test cases, right? Because algebra, first of all, algebra can't handle whole numbers, number 1. Algebra is actually incapable of distinguishing whole numbers from non-whole numbers. So that's a strikeout already. But 6 variables, oh geez, that's going to be terrible. So let's just make 6 blanks. Or let's make 6 columns. So there are 6 columns. And these are going to correspond to how many reps we're sending. Let's say that this is the most on this side, the greatest, and let's say that this is the least over here. Which column is the column of interest? It's the second column, because that's country A sent the second greatest number of reps. So A is this column. And so this is where we want to be putting these numbers of 10 or more or 9 or less, right? Obviously, you can't highlight columns in your work, but what you can do is you can, put extra boxes or extra outlines around them. So you can do something like this. Every little bit of organization like that will help you. Okay, total of 75. Statement 1. One of the 6 countries sent 41 reps to the Congress. That's definitely going to be the country that sent the most. No doubt about that. What should we do with second column? What do you put where? Korea's going to tell us. Yeah, I mean, you know what? That's a good take-home point there, is that these are good values to try if you don't know what else to try, like the values on the boundary. Because if you think about how numbers work, like if you could get numbers above 10 or below 9, then you could also get 10 or 9, right? You're not going to have cases where numbers work, but the intermediate numbers don't work. That's not really a thing. At least not in problems like this. I mean, it'd be a different story if you had to do divisibility or something like that. But yeah, or you can do what Steve is doing. Either way, Steve's way actually might be a little bit faster way to get the first case. So let's try that at least. If you put those there, that's 41 and 10. That's 51, leaving you with 24. That's a check mark here. All right. What is our only goal in life at this point? Is to specifically put what number here now? Definitely a 9, yeah, because if it could be even smaller than 9, it will still work. So let's see what we've got, right? You don't have to try to find a minimum. No, so you actually don't. Because you don't care. You don't care about minimum values. No, you don't. Because you only care about can I get 10 or more and can I get 9 or less. It's finding the minimum here would actually be considerably more involved. Because finding the minimum of something that's not the smallest or biggest number is actually kind of hard, especially when you have when you have different values that are mandated to be different. So no, you don't need to think about minimum. Nope, goals. Goals. Remember, that's the title page of this lesson. Goals and data sufficiency. No, minimum is not a thing. We only, if we can get it to be 9, that's small enough for us. Smiley face if that makes sense to you guys. Super important. If you're trying to find the minimum, it's not an efficient way to do it. Okay. All right. That's 50 so far. We got to distribute $25 more. So let's just try to put 8. Now we have $17 more. Now we have $10 more. And we can do that. That works. So we check the other box. Statement 1 is not sufficient. All right. Statement 2. What should be the first case that we use for statement 2? There's a good answer to this one. There's definitely a most efficient answer to this one, given what we already have up on the board. Yeah, the second set we just created is a good place to start because it still works. I mean, yeah, you guys have an almost divine manifest destiny to be lazy when you do these things. Be lazy, people. Be lazy, my friends. Because laziness is actually efficiency. There, I said it. Okay, let's just replicate that case, because why would we do work when we don't have to? That would not be smart. Okay. That still works. And we can check off this box. All right. Now we only care about getting what value? Just 10. What's a nice, efficient way to do that? Can anybody think of a relatively painless way to do that? Yeah, yeah, you could do that. I'm thinking even more painless than that, though, because you would see you're still having to do arithmetic there, and I don't want to do arithmetic. Plus, I think it would actually be 55 and not 60, but yeah, what? Not from 8, but you want to subtract 1 from, ironically, the 8 and 7 are the only places you can't do it, but yes, that's the right idea. Because we just added 1 here. So let's be lazy, my friend. Laziness is efficiency. This went up by 1. I don't want to do all that adding to 75 again. If I take 1 away from somewhere else, then I'm totally cool. So I can just make this 40. And then I can just leave everything else the same. Or you could have taken it off the 6 like Mike just did, or you could have taken it off the 4. Actually, you could have done any of those things. So this is not sufficient. Actually, I like Mike's idea better. Does anybody know why I like Mike's idea better? Let's leave the 41 alone, and let's take it off of the 6. Why is that better than what I did first? Yeah, because the 41, I'm looking forward to combining the statements, and if I make a case where this is 40, then that case won't apply to statement 1, and I'm thereby creating more work for myself. So ideally, I'd like to not touch the 41. So yeah, that's what I accomplished by doing this. This is good stuff. So check box there. But then, you know what? I mean, both of these actually satisfy statement 1. So no more work to combine the statements because both of these still apply. And so I can still check both boxes for combined. And so this is still not sufficient. It was not sufficient here. It's still not sufficient. So this is E, like elephants. How about that? Any questions about this problem? Are there any veterans here who know how I'm going to answer that question? Because you might know how I'm going to answer that. I'm going to answer it the same way I always answer it. Yeah, 2 is the average. I mean, this problem is pretty clearly longer than the average. So trying to do this in 2 minutes is not a smart plan. The averages are not limits. They are averages. I mean, you're going to go over 2 minutes as often as you go under it. So, no sweat. I mean, the point is, okay, so back to, well, let's see, okay. This question, if you remember, this question was put on the board in the context of, what I was saying was, stop when it's time to stop. That's that Han King was talking about here. So, I have good news for you here, which is that the instinct that you need is the instinct that you already have literally everywhere else in life, except for these weird places called classrooms where people are not smart. So here's an example from the real world where people are smart. Let's say you're driving somewhere. Okay, then you realize that at any given point, you are either not lost or lost. Okay, note that if you think you're like, I might kind of sort of think that I might kind of maybe be lost, you're lost. And you would realize there's not really a gray area there. I mean, you either have a very broad sense of where you are going or you don't. I mean, it doesn't have to be exact. I mean, you can know, it's good enough to be like, okay, the freeway is that way and I have to go find a ramp to get onto it. I mean, that's good enough to get you where you're going. But other than that, it's binary. You're either lost or you're not lost. And the point is, if you are lost, you will not keep driving. You will not drive. You will not spend any time doing that. Like if you're lost, you won't spend any significant time driving in random directions and hoping that you reach your destination, because that's not what people do. In fact, if someone did that, you would probably think they were sort of insane. Or as another example, I think I've used this example several times before, but you're assembling furniture. Sure. Like from IKEA, ship flat, you have to assemble it kind of thing. I mean, then at any given step, you either know where the next piece goes or don't know where the next piece goes. And again, you're not going to risk ruining the project. So if I kind of sort of maybe think this thing kind of goes over here, sort of, kind of. Then no, I mean, you don't know where it goes, and you will stop. If you're lost when you're driving, you'll stop. If you are not 100% sure, where the next piece goes. Well, will you nail it somewhere random and hope? I probably not. Will you stop what you're doing and try to regroup? Yes. So you have the instinct, and notice that you will not waste a lot of time here. Like, you will immediately stop as soon as you are not directly headed towards a goal that is clear. On the other hand, in classrooms, people do the equivalent of this. They do it on the regular. They do it all the time, right? Push numbers around and hope that something cool happens. That's a lot like just driving on random streets and hoping that you get to that concert you're going to. You know what? You're not going to get there. Not happening. Or like nailing together random boards of wood. You know what? It's not going to turn into a piece of furniture. It's going to turn into a ruined project and a wasted day. So why are people in classrooms such weirdos? I mean, this is something that you should think about. Because these things are, in a word, these things are crazy. Like, either of these things would, frankly, be crazy. But in classrooms, people do the equivalent all the time, which is just, shoving stuff around or doing random steps all the time. People do it all the time. Why? Why do they do it? There's a reason. It's a definite reason that has to do with incentives. That's the reason. It's because they reward you for doing it and they punish you for not doing it. I mean, the worst thing you can do would be like stop and say, I don't know how to do this. That sort of honesty, nope, you don't get rewarded for that. I mean, partial credit is a very, very, very evil thing, and it is also very pervasive. Because it teaches you that there is good to be had in like literally random steps with no goal, even if they basically ruined the project. Because, yeah, see, the thing, though, is that effort is not a good thing when it's not directed, right? See, that's the problem. I mean, we don't want to reward people just doing random crap, because think about building stuff. I mean, if you put a whole bunch of extra effort in and the result is that you ruin the project, do we want to reward that? No, we don't. We don't want to reward that. So, I mean, that's probably the reason for it, ultimately speaking, sure. But it's not a good thing. So that's what you have to defeat, right? So basically the take-home point of all of this discussion is you just need to import. First of all, you need to identify the source of the problem, which is partial credit. That's step one, because you can't defeat an enemy that you can't identify. So the first step is to identify why this is a problem, because it would never be a problem in the real world. It's really not. And that this partial credit is the reason. And realize that there's no equivalent of partial credit here. In fact, there's negative partial credit here because you lose time. That is valuable time. And then what you want to do subsequently is you just want to import the perfectly workable mentality that you have here. So, sure. Like put yourself in the mental state of I am like assembling something under time pressure. Like you wouldn't do random steps because you know that undoing stuff is a lot worse than doing it. So that's basically the deal. I mean, so the good news here is that you don't need to learn anything new. I mean, time management is not some exotic flavor of weirdness. It's something that all of you do every day. if you ever like drive somewhere or make plans or build things or anything at all really, but except for classrooms. So you just have to kill that weird way of thinking and import this one. So that's your job. But just put yourself in that frame of mind. It'll be fine. Okay. Any other questions about? I suppose the other response to this would be like you got to think long term. I mean, a lot of people are just thinking only in the frame of this one question, like, oh, I might have to guess on this one question. But you need to think about it in perspective. It's I might need to guess on this problem in order to let me finish the other question. I mean, don't just think if I keep working, I might get it right. I might have some light bulb moment. If I keep working, I might have some light bulb moment, but I'm stealing time away from the other question. You got to think big picture. So there's my very long-winded answer to that question. All right, let's talk about this problem. Actually, before we talk about this, just kidding, let's talk about this one again really quick. Because notice the organization. I mean, this organization is far from genius. This is not nearly genius. This is like, dude, I made 6 columns. But notice that if you don't make 6 columns or some, you're welcome, by the way, Hakeem. If you don't make some equivalent of 6 columns, there is no way. I mean, in other words, what I need to write in a very large size font here is do not try to do this in your head. Don't do it. Even if you probably won't succeed. I mean, I hate to be a pessimist, but yeah. I mean, they've had studies on this, and they show that the error rate of mental math is somewhere between 40 and 50 times the error rate of paper math. Yep, 40 and 50 times. So if you want to make 4,000 to 5,000% more errors, then do it in your head. If you would rather not make an additional 5,000% of errors, then don't even think about it. And it'll be slower. Like even if you manage, it won't be fast. I mean, it'll be much, much, much slower than doing it on paper. Trust me on this one. But yeah, don't do it. Organize, even if it's rudimentary, even if it's just I made 6 columns, dude. All right, let's talk about this problem. Go for it. You know where to find multiple choice responses. There you go. By the way, every answer choice has been selected by at least somebody, so you don't need to feel bad if you have to guess. By the way, the flip side of our, 2 minutes would be an unwisely aggressive timeline for the previous problem, but this problem has very few black pixels on the white background. In other words, there's not a lot of stuff in it. So if you take 2 minutes on this problem, that probably means issues. Shouldn't take that long because look at it. It doesn't mean it's easy. It just means that there's not a lot of stuff in it, and you got to have that honesty going on with yourself. Let's get some answers on the board. If you are AK, Brandon number 3, Fahad, HBB28, Linda, Nico, Nirav. But I can't force your hand here, but remember that you can't skip problems on this exam, so don't get in the habit of it. All right, let's discuss. All right, it's kind of annoying when they do this, but when they stick an if in front of this, someone tell me what that means. It means it is true all the time, right? Like, what's interesting about this is that when that's like a sentence with words in it, very few people seem to have trouble interpreting it. For example, if you saw like if n is an integer, then blah 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 blah, then like everybody in the world seems to immediately understand that this means n is always an integer. But then for some reason a lot of people don't make the same connection here. This is the same thing as that. Like if they tell you if n is an integer, then that means you do the entire problem subject to this constraint. So throughout the entire problem. And then again, that seems to be weirdly less of a problem when that's words. But just take the cue there. So what you can do, what I like to do on Scratch work, is because that is true the whole time, and because it must remain true the whole time, what I like to do is just import it into both statements. So in other words, just put the word and in there. And then just write that. Don't write it that big. And then just, that'll make your life a lot easier. I mean, this is not a major task, but wow, look, this problem just got a bunch easier. And now we can sort of obliterate it from that part either. That's the real question. That is much nicer. It just is. I mean, like, just lining these things up with each other probably gives you a whole load of ideas about what you can do with them. That like, just look at this, right? Just look at, in particular, look at the similarity between this and that part of that. We're onto something there. But let's make our device first. Let's do it. The yes case means that v is actually greater than 0. The no case technically means that v is less than or equal to 0, although you can't get 0 with these statements. So, but still. And let's put the vertical separators. So we got statement 1, we got statement 2, and we might have both of them. We don't know yet. Can someone tell me a story about that? They don't say the same thing. Yeah. Because to get from one to the other, yeah, all right. See, you know what? I'm going to sort of, I apologize ahead of time. I'm going to kind of pick on Steve here for a second. Constructively. I'm going to pick on you in a way that's constructive. So that's the kind of thing, that's the kind of oversight that would be understandable in most cases. Because you probably know, Steve, just verify this with me, but you probably know that if v is negative, then that's not true, right? Are you on board with that? Because negatives will flip-flop that inequality sign. If you... Yeah, okay. So, but you forgot. Forgot is not the same thing as did not know, right? Forgot is fine. I mean, as long as you know it somewhere. It's a thing that you've learned before. Okay. So my point is that, all right, here's the opening screen again. Yeah, this. That's a thing. I mean, remember that this entire problem revolves entirely around the sign of v. And so that's what makes this not an okay thing to forget. Like, like basically this would be it would usually be understandable if one were to forget about maybe V is negative dot 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 dot, unless the entire problem is about whether V is negative, smiley face, smiley face, smiley face. I mean, goals, right? Like you all, at all times, this is the focal point of your thoughts. Like you don't just blindly look at this. You look at this with this constant thought in your mind about the sign of V is the thing I need to be thinking about. So, and again, in the real world, people are also very good at this. They are very good at it. Like if you're talking about cost cutting at a company and you're looking at all of the company's activities, it's not very hard to like only look at the cost element of those activities. I mean, most people can do that. It's not very hard, right? So for example, if it's like recycling motor oil, you're not concerned with the environmental part right now because you're only concerned with the money part right now. It's kind of like this. This is like you're only concerned with the profit aspect. You're only concerned with the sign of V. So this is consuming your brain right now. And in that case, you should definitely make that connection, right? So if you know that if I know, all right, I'm done picking on Steve. But take home point for everybody, not just for Steve. So if I know that M is less than P, then well, if V is negative, then MV is actually greater than PV, and so this statement would be not true. So what you should take, because those have to both be true, so you should just take this to mean that V is not negative. And of course, if V were 0, then MV will equal PV because they'll both equal 0. So V can't be 0. Oh, that means that there's only one possibility left, which is V is greater than 0. We know for sure. So this is possible. This is impossible. So therefore, it's sufficient. The other thing that is a take-home point here is, we're dealing with this problem type called sufficiency. And sufficiency is, like roughly, very, very roughly speaking, sufficient and not sufficient are related to the ideas of works and does not work. Like they're not exact analogs for each other because sometimes sufficient means doesn't work and vice versa. But like the point is that the entire point of data sufficiency is to call you out if you make assumptions that are not true, right? So the entire point of data sufficiency is to test you on exactly when these sorts of statements are true. So just make sure, before you ever casually equate things, just make sure that you really can do that, because in data sufficiency, it's all about due diligence. I mean, this is not advanced mathematics, but it's just you have to really, really, really be on point with that ground level stuff. Any questions about statement 1? Smiley face if we're good. So statement 1 is sufficient because we cannot check both boxes. Statement 2, what letter is not relevant to our lives anymore? Yeah, because remember, that's the goal. That's the all-consuming thing that is consuming our brain. And this is M, and this is MV already. So PV is not really, we don't care so much. So let's just kind of not Let's not then say we did. All right. So then I think you can see what the deal is, right? If the product is negative and M is, because negative product means that one of them is negative and one of them is positive. So if M is the negative one, then that leaves V as the positive one. So that is also just that one and not that one. So this is also sufficient. And we have D like dog. How about that? So a bunch of take-home points here. They're mostly, as always, they're mostly organizational points. Like if you have an if blah 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 blah, then you can just kick that down into bulk statements. I would suggest actually writing this on your paper, because there's an effect that I mean, as soon as you write these two things next to each other, your brain will start making connections that are not as easy to make, that will not be as forthcoming if this is still upstairs and this is still down here. So, you know, the key to this can be as simple as, yo, take that statement and copy it twice. It's not high level stuff, but it's important. And then there's the device. And finally, most importantly, goals, guys, goals. Keep this in mind at all times. This is all you care about, is assignment B. Neato. All right, let's do a problem. How about that one? Again, there's a lot of words on the screen. What's LOL? You know, when there's a lot of, if it's the problem, if it's just like the stuff in the problem being scary looking, I mean, when they give you a lot of words in a formula, in general, the major step of that process is going to be plug into the formula. It won't be as scary as you think. The ones that have the more elaborate thought processes are oftentimes the ones that don't have as many words or whatever in them. Like here in that last problem, you had to do a very non-trivial number of steps, you know, and you had to realize a lot of principles about positives and negatives and what have you. Here, you're probably just going to plug in, but give it a shot. Again, you don't need to finish this in 2 minutes, because look at it. But you know where the multiple choice answers are. There, they are. They're here. Oh, you know what? You're right. I didn't clear the answers. Okay, I just cleared them now. So if you already had an answer to this, please be so kind as to re-input it. Thanks. Thanks for the heads up. Okay, I didn't turn the mic on. Let's check some answers. For some reason, it's the first half of the alphabet that's not answering the question very much. In fact, except for Nico, everybody from J through Z has answered it so far. But AK, Chris, Chuck, Fahad, HBB, Janesh, pick some things. All right, let's discuss, shall we? Make our, remember where the multiple choice answers are. Multiple choice answers are there. Underneath your name, letter A, click it, you'll see it pull down. There it is. Okay. Let's make that device. Let's do that. Let's always do that first. So the yes, equivalent is the interest rate is greater than 8%. The no equivalent is the interest rate is less than 8%. I guess the 8. I always confuse dollar signs and percents, which one goes on which side of the number. So my bad there. And then let's make rows and columns. Statement 1, statement 2. Okay. Yes, it could. It could include. You are correct. Good eyes. Yeah, I'm testing to see whether you guys are paying attention. So you guys just passed that test. I swear that's what I was doing. Okay. Let's look at statement 1. How long did you guys take on statement 1 after having read the words in the question? How long did statement 1 take you? Like literally how many seconds? 30. 30 is kind of a lot. 20. That's kind of a lot. Oh, no, we don't want to do that. Don't do that. That's pain. Let's have a chat about statement 1. Okay, statement 1. So that they tell you that n is 2, so we can sub in 2 for n. And they tell you that the I is 210. Yeah. Okay. Let's try this again. How long should this take you? It should take about 1 second. It might take you 5 seconds maximum if you are if your coffee hasn't kicked in yet or whatever. But how many values of R is this going to give you? I mean, it's only going to give you 1, which is, you know what, you might not even have to set up the equation to realize this because it's just kind of common sense, right? Like you have a fixed number of years, and so the only thing that can change is the interest rate. So if they give you a fixed number of interest, then even if you don't write this, that's going to give you a single value. I mean, you might still want to write the formula just to be sure that there's not 2 or more variables floating around here. But there's not. There's only going to be 1 R that does that, because if R is any bigger, it'll make more interest. And if R is any smaller, it'll make less interest. So this is only 1 value of R will come from this. Do we care what that value is at all? Because goals. Remember, the goal is to see whether we can fill both of these boxes. We definitely cannot fill both of those boxes. So you have to hit both of those to get not sufficient. That's definitely not happening. I mean, I can't be over 40 and under 40 years old at the same time. I mean, if you wanted to have over 40 and under 40, you got to have 2 people. So same sort of thing here. I mean, we're definitely stuck with one of these, and we don't really care which one it is because it doesn't matter. I mean, because that's the goal. The goal is just if I can tick off both of those, then it's not sufficient, and if I cannot, then it's sufficient. So this is sufficient. I mean, it doesn't matter which one. It's going to be one of these. Doesn't matter which one. because it doesn't. That's sufficient. Smiley face if we're on board with that. Sweet. So if you did spend all that time, I mean, when you review the problem, just make sure that you inventory like, whoa, I did all this work here. Because I mean, that's the other thing. A lot of people only think about whether they got problems correct or incorrect, and they don't think about, efficiency points. But you definitely got to think about that. Statement 2. So we don't want to have to solve that, do we? I mean, that's sort of icky. We don't want to have to solve that. Do we? What can we do instead? Plug it in. What is it? We should test for 8 because the goal is 8. We only really care about 8. Incidentally, if you know about compound interest formulas, you might save a few seconds here by realizing that 1.15 represents a 15% gain. Although, so compounded interest of 8% is going to be more than 16%. You don't have to realize that to do this, but that is, if you know what these formulas mean, then you can do that. If you don't know, it doesn't matter. Let's just do stuff and not do stuff. So yeah, let's just put 8% in here, which is our boundary value, and then just see what happens, right? Just try 8. So that expression would be, and we only care about that part of the expression now because the words in the problem don't matter at all anymore because this is a formula, this is an equation in terms of R. It's a totally disembodied equation that has nothing to do with we don't need the words to solve it. This could be a pure algebra problem from this point onward. So if we plug in 8, so let's rope that up there. If we plug in 8, then we get, so even if you don't know what it means, it's fine. I don't want to make this a class about interest formulas because you don't need any knowledge of how interest formulas work ahead of time. You don't, so it's all good. This is going to be 1 plus 8 over 100 squared. So that's 1.08 squared. So that is, okay, here's the longhand way to do it. It's your straight up multiplication, so that's going to be, what is it, 8 times that is 864, and then 0, and then 108. So that's going to be 1.1664. There's also a kind of cool way to do this, which, remember, you'll get a calculator, so here's another neat way to do this. If you like binomials, you can also multiply it out like this. So that's 1 squared plus 2 times 1 times 0.08 plus 0.08 squared. Again, it all depends on your skill with this kind of stuff. This might be faster for you than longhand. So this is 1 plus 0.16 plus 0.0064. That if you're not used to doing that, it'll be slower at first. But if you get bored, you can practice it, and it might turn out to be faster than longhand. So it's kind of neat. And if you're me and you make math mistakes all the time when you do arithmetic, I would do it both ways. Because if I get the same answer twice, I didn't make a mistake. So hey, all right. So the deal is, if you plug in 8%, you get more money than that. I mean, you might not know what this number is, but it should be clear that the more money you get in interest, the bigger that number is, because it's getting multiplied by stuff, and the result is interest. So statement 2. Tell me about the R that gives this number. Will it be less than 8 or more than 8? Remember that 8 gives you 1.16. So to get 1.15, yeah, R is less, right? So basically, that 1.15, that value comes from some R, which is less than 8. So this statement can translate into R is greater than something under 8. Because basically R is anything bigger than whatever value gives you 1.15. I mean, let's just say it's 7.5, just to make this more concrete. Like, it's not going to be exactly 7.5. Let's pretend. If 7.5 is the value that gives you this, then this statement reduces to R is more than 7.5. So that's the thing, though, right? If it's more than 7 point something, let me write it that way. R is greater than 7 point something. So if R is greater than 7 point something, that means it can definitely be more than 8, but it can also be between 7 point something and 8 inclusive. In fact, all this work that we did down here? I mean, this is a value that is greater than 1.15. So that actually that checks off this box. Because 8% clearly works. So if R is 8, then it satisfies the statement. So less than or equal to 8 gets checked off. So, and then so even if you don't think about it in this blue way, I mean, once you check that box off, it should be extremely clear that you can check off this box, because this is like things are greater than, I mean, this could be as big as you want it to be. I mean, this could be 10 million, 1,000 billion if you want it to be. So R can definitely be big. So, but basically the arrow I'm drawing there is like this work proves that R equals 8 actually satisfies the statement. So thereby ticking off the 8 box. That once you realize that the other boxes do, and my internet decided to be a hater there for a second. I mean, this work shows you that the case of R is 8 actually works, and so that ticks off this bottom box. And then it's probably pretty clear that you can take off the top box, because you can make it whatever, you can make it as big as you want. So this is not sufficient, and so we have A alligator. And that's pretty neat. Let's see, it looks like 1 or 2 people are typing. So I'll wait to see what you are typing. Okay, no, I guess not typing. Let's do a quick one. We can cram in one more at the time we got here. Well, let's make that fit the screen. There we go. You know where the multiple choice answers are. That's where they are. Go for it. All right, let's fast forward through the discussion of this so that we can end on time. Yeah, remember there are basically two ways. By the way, most people pick B, boy, or E, elephant here. And there are a sizable number of people picking both of those. But any day efficiency problem in the world, you can do one of these two, but not, median. There's no algebra way to do medians. I mean, the median is a non-algebraic concept. So, except in very limited circumstances. Like, the only way you can ever do a median algebraically is if you have formulas that are in lockstep all the time. Like, if you have x plus 1, x plus 2, and x plus 3, then your median is x plus 2. But unless you have things that are literally always in the same order all the time, then you can't do it algebraically because it doesn't work. So that leaves you with testing cases because this is not accessible to algebra. So this is going to not be a thing, and you're going to do this. Okay, let's make our device. So the yes case here is Z is the median of, notice that Z is one of the items too. And the no case is that it is not. Okay, how about that? And then statement 1, statement 2. And then, if necessary, the combined version. Those are big. I don't know why they're so big. Okay, no, they're less big. All right, so, yeah, and when we do testing cases here, remember that there are 2 secrets to success on this exam and in life in general. Does anybody know what they are? If you've watched these things before, you know what I'm going to say, right? It's not that. I mean, because you don't know what the easy stuff is until you do it, in general. I mean, you're not going to know what the easy stuff is. So, there they are. Do stuff and don't not do stuff. Okay, do not sit there and guess how it's going to turn out. That's called not doing stuff. Do not sit there and speculate. That's called not doing stuff. I mean, just start throwing some freaking numbers in there and see what they do. Okay, so, yeah, let's do it. All right, statement 1. Let's pick X, Y, Z. And then you could remind yourselves of the condition. I mean, I would just write it out on there because there's no harm in writing it out on there. So X has to be less than Y plus Z, and then median. Okay. So, well, 1 is less than 2 plus 3, so, and the median of those is 2, which is not Z. So let's check off that box. What's our only goal in life? Well, we want to make Z the median. Oh, well, I can, as soon as I realize this is Y plus Z, I know that I can switch Y and Z with complete impunity because Y plus Z and Z plus Y are the same. So this time the median is 2, which is Z. All right, I did it. It's not sufficient. Yeah, statement 2, just make Y and just do stuff. Really, just do it. If you do stuff on statement 2, you will immediately discover how statement 2 works. I mean, I'm looking at you, people who didn't pick the right answer here. Yeah. Y and Z has to be the same. So let's just put in some things. You'll very quickly realize how this works. I don't know, 5 and 5 and I don't know, 14. Well, the median is 5. check it off. How about minus, I don't know, minus pi? Because no, it's positive integers. So how about 11 and 11? And oh, I think I see what's happening, right? Because I'm doing stuff and I'm not doing stuff. The median, there's going to be an 11 in the middle. So basically just go until you're convinced it's going to happen every time, but it will definitely happen every time. So this is not happening. This is sufficient. This is B. Boy. Because you can't have 11 whatever 11 unless whatever is also 11. Because these things are in order. So if you have basically the idea that you will very soon you'll very quickly discover that Y and Z are either the first two numbers or the last two numbers. So either way, the middle is one of them. And so it's going to always be the same. It's going to be the same as Z. So if Z is the median, that is the question. That is the question. That's the same thing. There's no, you can't specify that the only way that you could do that is if you actually added a condition that said that the numbers had to be different. But then if you had that, then statement 2 couldn't be this anymore. So, but is Z the median and is Z equal to the median? Those are the same question. I mean, Y and Z are both the median. So, remember, they're not going to play games with words. There are no tricks ever, no tricks on this exam. If there's any tricks happening, it's you tricking yourself. Don't do it. Okay. With that said, we got to close up shop here. Thank you guys for attending. Probably going to do some sort of verbal animal next time, but we'll see. We'll see what happens. These decisions get made like 30 minutes before the session, so we'll see. Thanks a lot for coming. See you on the recording. Good night, good afternoon, good evening, good